Assalamualaikum warahmatullahi wabarakatuh and good afternoon I wish to every one of you. So for today, our group will present about design for refrigerated container, and we are from SEMM 3443 Heat Transfer Section 3, and our lecturer's name is Dr. Aminuddin Saad. So introduction to our group members. My name is Muhammad Aiman Ramli, and accompany with me is Fahmi Yaseer and also Muhammad Azhad Irfan. So before we go into the main part, we will first introduce to you what is our project. So nowadays, people are easily thinking of things that can be done faster and also cost saving. Okay, so frozen food is being the best choice compared to other food such as processed food and also fast food because it can long last in a long period of time but in the cold condition, and also it is easy to cook when we have desire to consume it. So as the demand for the frozen food is growing, so the delivery service of the frozen food also need to be improved because the temperature inside the container of the frozen food is critical, and we need to have it in the control condition so that the frozen food will not be damaged when arrive at the destination. Okay, next we will go into the objective for the project. So in this project, we will focus to do analysis for the frozen food inside the container. So some of the objectives of this project are we want to know the rate of heat transfer between outside and inside the container. We want to apply the knowledge learned in heat transfer in solving the real life problem, and also we want to improve the existing design of the container truck. So for the case study is the questions that being asked in the project. Next. So this is our design description. First, we will go into the drawing of the container. So the dimension of the drawing. Next. So the dimension of the drawing is 6 meter long, 3 meter height, and also 2.5 meter width. Okay. Okay. Next. So for the assumptions, so we have divided the assumptions into two categories. For the first part is assumption made for the situation. So firstly, the container will bring the chicken nuggets. Our frozen food is chicken nuggets from Johor Bahru to Kuala Lumpur. So the nugget will be inside the packaging shown in figure 3. So there will be 17 packaging nugget inside the box, the chocolate color. Next, every single packaging has a weight of 1 kg. And the distance between Johor Bahru to Kuala Lumpur is 335 kilometer distance and will take about 3 hours and 34 minutes. For the second part of the assumption is the assumption for heat transfer analysis. So the container wall will have two layers, which is fiberglass and on the outside layer, and stainless steel AISI 302 at the inside layer. The thickness for fiberglass is 25 millimeter and stainless steel is 100 millimeter. And heat transfer through the wall is steady. So the surface temperature remain constant at the specified value. The outside temperature is equal to the ambient temperature, which is 38 degrees Celsius, as mentioned in the question. And also the inside temperature is equal to 0 degrees Celsius. So for the properties of the material, so we find the thermal conductivity for fiberglass and stainless steel is what shown in the on the screen. And also the convection coefficient also we made assumption for the outside convection coefficient is 150 and the inside container is 50. So I pass to my next colleague to explain about analysis of heat transfer.
Okay. Testing. Okay, so we move on to the analysis of heat transfer. Firstly, we are going to analyze from the side view of this truck, and there are two cases that we include here, which are for case one, 2 layer of container, and the case two, 3 layer of container. For the case one, first of all, we have listed all the parameters, and we provide here the figure. This is from the outside of the truck, and T outside is 38 degrees Celsius, and uh, this is the glass fiber layer and stainless steel, and this side is the inside of the truck. Here we are going to find and determine the value of R, which are R outside, R1, R2, and the R inside. So this is all the calculation here, and after we get all the value of R, we just add them and we obtain this value. Okay, for the case 2 is the improvement from the case 1, which is we add another layer of fiberglass after the stainless steel. So this is a view from the outside truck: fiberglass, stainless steel layer, and fiberglass layer, and this side is from the inside of the truck. So we all know that R1 and R2 is the same because it is glass fiber. We just add them all here and we obtain the R total value. So we move on to the steady rate of heat transfer, Q dot. For case 1, we obtain about 846.87 watt. Meanwhile, for the case 2, we obtain 455.36 by this equation, using this equation. Okay, so this is for calculating T1 and T2 for both cases. For case 1 here, T1 is equal to T infinity 1, and we use this calculation. And to calculate convection heat transfer coefficient, Q convection, we use the equation. This equation, which is H outside times surface area, we open bracket, T infinity 1 minus T1. So we obtain this value, and this is for the case 2. Okay, we move on to the top surface of the truck. Same like before, for side of the truck, we include all the parameters and also the figure. Figure is also the same, likely from side of the truck, and we calculate first the R value for each part from the outside, for glass fiber, for the stainless steel, for inside of the truck, and we add them all and we obtain this value using this equation. Now for the case 2, same like before, we just add another layer of fiberglass after the stainless steel layer. R1 is equal to R2. Using this equation, we obtain this value, and then we just add up them using this equation. So the steady rate of heat transfer, we use this equation: T infinity 1 minus T infinity 2 minus R total, and this is for the both cases. You can see here the difference here. Okay. Next, we move on to the calculating T1 and T2 for both cases. Same like before, for the side of the truck, this is for the top of the truck. And we obtain the value here using this equation. T1 is equal to T infinity 1 minus Q dot R outside. And this is for T2, and for case 2, and this is for T2, case 2. Okay, next, for the Q convection, we use this same equation, which is H outside times is a surface area, open bracket, T infinity 1 minus T1, and then we obtain the value of Q convection for both cases, which are case 1 and case 2. Okay, now we move on to the discussion for the analysis part. From the calculation of rate of heat transfer and T2 on the side of the truck, we obtain the value of Q dot is equal to 846.87 watt, and the value of T2 is 4.71. So this indicate that we need about 846.87 joule of energy to transfer inside and outside the container wall per second. So in this case, there is quite high amount of heat loss from inside of the truck container to maintain it at 0 degrees Celsius. And we calculated the T2 inside of the surface truck 4.71, which is close to temperature that required, which is 0 degrees Celsius. Next, the rate of heat transfer due to convection at the outside of the truck is 891 watt. So for the top of the truck, we obtain the value of steady rate of heat transfer Q dot is 705.68 watt. This is slightly lower compared to Q dot at the side of the truck. This is affected by this is due to the total resistance at the top of the surface is higher compared to the side of the surface. Furthermore, we can clearly observe that there is no much difference between T1 and T2 for both surfaces at the side and the top of the truck. Then we detected the rate of heat transfer due to the convection from the side of the truck and the top of the truck, which is 742.5 watt. So the value of Q convection for top of the truck, we have calculated before, is slightly lesser than the side of the truck. This is because due to the surface area that involved with convection. We know that the surface area for the top is lesser than side of the truck. So we can manipulate the value of rate of heat transfer for both sides at the top of the truck, as it has effect directly to the usage of dry ice. The higher the value of heat transfer rate, the faster the dry ice will be evaporated. This will lead into increasing on costing, inefficiency, and ineffective delivery service of the frozen food. Next, I pass to my another colleague to explain about amount of dry ice needed.
Okay. Thank you, Mr. Azhad. So for the amount of dry ice needed, we have choose this table as our reference. So based on the figure shown in the screen, we can see that the left of column of the table is the weight of the frozen food, while the right side of the column is all about the time or amount of dry ice needed for the delivery service. So in considering the time, firstly we need to know the weight of the frozen food. So as what we have considered previously in our assumption, we will put the packaging of the nuggets inside of a box. So the box will carry 70 packagings of nuggets, and we can assume the weight of each box is 17 kg. And if we change this 17 kg into pound or English unit, we will get 37.48 pound based on the conversion unit shown in the inside of the rectangle shape. Okay. Next, we also need to consider the time, which is the distance between Johor Bahru to Kuala Lumpur. So as what we assumed previously, the distance is 335 kilometer, which take about 3 hours and 34 minutes. So we can say that if we can see the table again, so we can see that the distance is near to 4 hours, and also the weight is between 20 pound and also 50 pound. So the weight of the dry ice that is relevant for us to choose is between 5 pound and also 10 pound. So to get the exact weight of the dry ice, we have to do interpolation. So when we do interpolation, we got the dry ice is 7.93 pound, which is after convert it to SI unit, we got it 3.56 kg, and we round it to be 4 kg for the weight of the dry ice for each box. So I pass it to Mr. Fahmi.
I will continue this presentation about approximation cost of dry ice. Okay, so for the design of our refrigerated container, we will use dry ice as our refrigerant. Okay, so we estimate that the size of dry ice compartment is related to the sufficient to maintain the temperature inside the container. Dry ice, as we know, dry ice is used in the food and agriculture industry, for example, to protect food from rotting during transportation. So for this case, we use about 100 packaging boxes which are filled with a pack of nuggets inside the container. As mentioned before, we use the nugget for our delivery good. So the size of the box, we assume that is about 17-inch long, 12-inch width, and 22-inch height. So we assume about 17 packaging of nugget can be filled by a single box. That is, we will use about 4 kilogram dry ice will be divided into 4 pieces of slice and 2 pieces of slice at the top of the box, and another 2 pieces will be put at the bottom of the box. Okay, for this position is to keep maintaining the temperature of the frozen goods. Okay, this picture is about the arrangement of the dry ice inside the box. As we can see, we put the at the bottom first we put the plastic liner which is made from styrofoam to keep the heat inside, and the next is we put the dry ice block, 2 pieces of dry ice block about 2 kilograms, and then we put the product which is a nugget, and after that we put 2 pieces of slices of dry ice, and the last one we put the insulated container lid which is made by styrofoam. So for the cost, dry ice is cost about RM6 per kilogram, and here we decide to use about 4 kilograms of dry ice for each box. So there's about 100 box to deliver from Johor Bahru to Kuala Lumpur. So the amount of dry ice that will be used is about 400 dry ice or 400 kilograms, because one slices of dry ice is about 1 kilogram. So for the cost, that ice is RM6 for 1 kilogram. So that's a 400. We use about 400 kilograms. So for it, so the final cost is about 2,400 per trip. Next, we move to the method to improve design. Okay, so there's a lot of method to improve the design our delivery system which may be relevant to the sustainability issue. Okay, after research and having discussion with our group member, we found out some suggestion to improve the editing design of delivery of frozen food system. So for the first method that we use is we add on layer of insulation. By adding more layer of insulation into the editing, insulation would increase the distance between inside surface and the outside surface of the container, and it would affect the heat, and it will be difficult to be heat to be transferred. Okay, the second method is we improve the aerodynamic design. This method is because, as we can see, the delivery truck is took a long time period and go into many different places to deliver the product. So it will cost a lot of money to fill the fuel, and also cost a lot of time. So we will improve the aerodynamic design to save time and also to save the cost. And beside that, it also decrease air polluted caused by the diesel being burned by the truck. Okay, so the next method is we change from internal combustion engine in the truck into the electric vehicle. Based on the data and the news from the internet, we found that in recent months, electric automobiles have increasingly become popular in our society. So this method we suggest is why we suggest is because according to the Good Energy in 2017, the electric engine in an electric vehicle run on a closed circuit, so it does not produce any of the gases that contribute to the global warming. So secondly is the petrol and diesel engine may require costly engine maintenance, but electric vehicles do not cost any engine maintenance. Okay, so yeah, this means that compared to the other vehicle, electric vehicle is expected to have reduced long-term maintenance expenditure. I will pass for the fourth method to my teammate.
Next we move on to the number 4 of method to improve design. So we can use renewable energy or solar because it is beneficial. If we can generate energy by using these renewable sources. Okay, according to Callahan 2017, the benefits that solar powered automobile provide make them a potentially attractive proposition for consumer looking for more environmentally friendly personal transportation. So as a result, researchers are continuing to work on producing solar-powered vehicles that are both affordable and reliable. Okay, we can see here figure 9. This is the design of the solar car. Okay, so the last point, we can improve design by traveling at night. The most cost-efficient suggestion to improve the design is by traveling at night. This is due to the lower outside temperature that eventually will reduce the rate of heat transfer between inside and the outside temperature and the outside container. This method also being used by several of the logistic companies as traveling at night is smoother compared to travel in the daylight. There are not so many cars on the road at night compared in the daylight. So we move on to the conclusion of our presentation.
Okay, so in conclusion, so delivery service of frozen food using dry ice is still possible to be done, but we need to improve the design, like what we have presented between case 1 and case 2. So case 1 is the existing design, and case 2 is the improve of the existing design, which we add a layer, insulation layer, and it helped a lot in reduce the the rate of heat transfer between inside and outside container. So we can say in this project we have achieved all of the objectives that we aim to achieve for in the early of the project. We got the rate of heat transfer which is 846.87 watt. We also have applied everything that we have learned in the chapter 3 heat transfer cost to solve this problem. And also we also have suggest some of the ideas to improve the existing design. So this project has given us some insights on how to make assumptions to help in simplifying the complex problem. So lastly, we hope that Dr. Amin and everyone can understand our presentation, and thank you so much from us.